morning, everyone, and welcome to the Safe Food Knowledge Network webinar today. We're going to let a few more people join in, and then I'll go through a little of the housekeeping. And once that is done, I will hand you over to Mairead, Mairead is my colleague from Safe Food, who will give you an introduction to our guest presenter, Lynn Patterson, today. So we'll give our participants a few more minutes to join in, and then we'll commence. So just before I hand over to Mairead, to let you know that all participant microphones and cameras are turned off. However, you are free and welcome to send your questions through to Lynn throughout the presentation, and you can do so by submitting them on the Q&A section at the bottom of your screen. Lynn will answer those during the question and answer session at the end of the presentation, and this presentation is being recorded, so a link to that will be sent on to you in due course, hopefully within the next couple of days. So that's all from me for now. I'll hand you over to Mairead, who will tell you a little bit about our guest presenter, Lynn.
Thanks, Tracy. Good morning, everyone, and welcome to the Safe Food Knowledge Network webinar on effective food safety for small food businesses. And this is the second part of our two-part series. So this part will focus on HACCP awareness and effective record keeping. And as Tracy just mentioned, we're delighted to have Lynn Patterson here as our presenter today. So background to Lynn, Lynn is Director and Principal Trainer of LP Associates in Belfast. Lynn has extensive experience in the food industry, in food product development, food safety and quality, and food training and consultancy. Lynn is also a registered trainer for high field qualifications and the Royal Society for Public Health, and she's also a visiting lecturer in Queen's University in Belfast. So Lynn's presentation will begin now, so I'll ask if all other panelists could turn off their cameras and microphones, please, and we'll start. Thank you very much.
Thank you, Mairead and Tracy, for the introduction. Good morning, everybody, and welcome to our session on HACCP and record keeping. I've worked in the food industry for over 30 years, and for the past 22 years, I have been working as the role of food safety consultant. Through this time, I've witnessed many good examples of effective application of HACCP principles. However, I've also encountered examples when HACCP hasn't quite worked, and I hope to be able to guide you through the pitfalls on this today. I've worked with both large and small scale food processors, manufacturers, as well as storage and distribution sites, and also catering as well. And that has included large scale catering, such as hospital catering. I'm fortunate to work in many associated businesses with the food industry as well, such as food packaging, and have experience in applying the HACCP principles within this industry as well. HACCP is a system which causes a lot of apprehension among those starting to apply the principles, and it is full of jargon, and I hope that the jargon will not put you off today. And I hope to take some of the mistake out of HACCP for you and guide you through the process to enable you to successfully apply the system in a manner which will benefit your business and will ensure that you have a robust food safety management system and thus produce safe products. It's important early in this presentation to clarify that HACCP is a food safety management system, and therefore we should be only looking at food safety hazards and not food quality hazards. You will have many more food quality hazards in your process, and so that we don't muddy the waters, we remove those out of our HACCP system and we concentrate our efforts on the food safety hazards only. So just to make that clear at this early stage. So HACCP is an acronym. It stands for Hazard Analysis Critical Control Point, and therefore the hazards that we're looking at here are food safety hazards. Food safety culture is nothing new to us. However, it's found a new voice in recent times. It is something that we need to set. It embodies the beliefs and values within your company, and the HACCP and food safety management control is central to this. As you can see from the diagram there, it's the values and beliefs underneath within your business which drive the behaviours moving forward. And HACCP is a system which is central to achieving these good food safety culture and values within your business. Behaviours to food safety control will be driven by the values and standards that you set as a business, as a senior management team. It's therefore important that we communicate these and lead from the top and ensure that they're achievable, providing the necessary resources. You have the responsibility to ensure that the culture is being achieved by monitoring, verifying, and reviewing. So you're going to provide the resources, train and communicate your values and beliefs, and then you need to ensure that you're monitoring and ensuring that those are being followed. So what are the benefits of having a good food safety management system in place? In other words, having a good HACCP plan in place? Well, it's a preventative, systematic approach. It's a proactive approach. So we identify all the current conceivable hazards that could potentially occur that perhaps have not already occurred within your business, that are realistically predicted to occur, and make sure that we manage those. So let's prevent making unsafe, potentially unsafe products and reacting when we do that. So instead, we actually make sure that we don't make unsafe products from the beginning. It increases our confidence in product safety. It allows us to identify potential concerns and failures that could happen, particularly useful when you have a new operation, which gives you confidence in the product safety of the products that you're producing. We want to be able to have that assurance that the products that we are producing are safe and are not going to cause harm to the consumer. It's an effective use of our resources. Resources are not widely available, so we need to target our resources and we need to look at where is it important. So control is transferred from end product testing, which is where we perhaps were using a lot of our resources in the past, into the design and manufacturing of our process and identifying key points in our process where perhaps we need to put more control. For example, we can target our resources around training, around the key parts of our process where food safety control is necessary, or from a maintenance point of view, we can actually look at key pieces of equipment in our process, which perhaps are maybe going to be critical control points, and ensure that those pieces of equipment are adequately maintained. From a legal perspective, HACCP is a requirement. So under European law, EC 852/2004, the Hygiene of Foodstuffs, under Article 5, it states that food business operators shall put in place, implement and maintain permanent procedures based on HACCP principles. And with that in mind, we are interested in making sure that we produce safe products. It does say based on HACCP principles, and that is to allow for some flexibility within the legislation. So it doesn't necessarily say that you have to have a purist HACCP system in place, which is what we're going to look at with you this morning, but there is an allowance for a little bit of a flexibility approach where we can apply the principles slightly differently, for example, in the catering industry. It also helps when we are having audits where your HACCP can be a central focus of these audits, and therefore the auditor can follow your HACCP plan, your process flow through, and use that as a central focus for their audit. It demonstrates management commitment by providing the necessary resources and ensuring that the HACCP plan has been carried out, the HACCP study has been carried out correctly. But on occasions, HACCP doesn't work. So I'm a great believer in HACCP as a food safety management system. However, on occasions, I've come across examples when this has fallen short. Well, why has this happened? Well, lack of knowledge and understanding by those involved, both in drawing up and implementing the plan. For example, not using a team approach, relying on one or two individuals carrying out the HACCP study, and they wouldn't have the necessary expertise in order to be able to do this. Perhaps relying on students on placement, thinking that they are going to be able to apply the knowledge. They have limited knowledge. They may understand the principles of HACCP, but they would have limited knowledge of your product and your process. Other examples are missing significant hazards and therefore not being in control, relying on buying in a generic system and hoping that that is going to manage food safety. No two processes are the same, therefore a generic system has limited value. Incorrect use of the CCP decision tree and therefore not identifying critical control points correctly, or not identifying all hazards. Perhaps the critical limits not being the point between safe and potentially unsafe product, or the monitoring not being sufficient to be able to detect whether we are in control or not. Lack of understanding, perhaps due to poor training, or having what we call a paper system. So all looks very well on paper, but it's not been implemented into our factory. Not keeping up to date, not being aware of new hazards as they emerge, or not considering changes in your process as and when they happen. So hopefully having an awareness of these pitfalls should be helpful to you and should make it easier for you to manage those. This is a model that I have created over the years to try and describe the hazard analysis process. So in at the top, we throw in all the potential hazards that could happen in our process. And then I put it through what I call a filtration process. So I have various filters, which are my questions in red in the model. So in at the top, under brainstorming, you would identify potential hazards in your process. So you'd be going through every step in your process flow diagram and you'd be trying to identify potential hazards. The first question, or the first filter, is asking, are these food safety hazards? Remember what I said, HACCP is only there to manage food safety. So if they are not food safety hazards, we can leave them behind. If they are, we pull them through. So we now have moved to level 2. In level 2, we have a slightly smaller pool of food safety hazards that we need to look at. So these are food safety hazards. Are they significant? What do we mean by that? Are they likely to happen? And if they did happen, would they cause some level of harm? So we now have significant food safety hazards pulled through to level 3. If they're not significant, we actually don't need to be worrying too much about them. Once we get to level 3, that is where I would say it is extremely important. We now are in level 3, we have significant food safety hazards. Codex says that all significant food safety hazards must be controlled. So here on in my model, that's where control must be implemented. So I now have significant food safety hazards, and I'm going to ask, are they being controlled already by prerequisite programs, PRPs? And I'll explain a little bit later what I mean by that. So prerequisite programs are general controls that we will already have in place. If we are happy that the PRPs are adequately controlling these hazards, then we cross-reference to those procedures and we will leave them at level 3. If not, we bring them to level 4. So we now have significant food safety hazards that are not already being controlled by prerequisites. We now need to implement controls. We need to make sure that they are going to be adequately controlled. So therefore, we put control procedures in place. Then we have another filter. Are these deemed to be critical control points? By definition, everything cannot be critical. So we now have our very final triangle at the bottom with a small number of critical control points in comparison to the number of hazards that we threw in at the top. So the last 3 filters, the last 3 levels are most important. And this is what we're going to be going through this morning with you. So management commitment is vital. It is part of our food safety culture. It is important that we get this. So this brings us back to the values of your business. We need to commit. What are we committing to? Well, what are the food safety objectives of our business? What are the consequences if we lose control? What could that cost our business? Is that something that we should be concerned about? How does HACCP relate to other systems, for example, quality management systems that you will already have in place? Many of your prerequisite controls will be already embodied into your quality management system. What's involved in setting up HACCP? Who should be doing this task? What should they be doing? How long is it going to take? Do I have that internal expertise available within my business, or am I going to have to buy in some expertise to assist me in the process? So it's important to understand that. We're going to pull together a HACCP plan, and the HACCP plan creates lots of documentation and indeed a number of records that you're going to have to develop as well. Oops, sorry, my presentation's moving on. So within the HACCP plan, you will have what I call the background information. So a bit of background to your company, a descriptor to your company and what you do. You will refer to the current legislation and any codes of practice which are relevant to your business, any standards that you're working to. You will include the scope of your study. In other words, what parts of your business are included and what parts are perhaps excluded from your HACCP study. You will have a descriptor of both your product and your process and your storage stages. And you will also include the intended use of the product. So what should be happening to your product when it leaves you? And then we have then our study. So we've got process flow diagrams, so mapping out of our process. We will have hazard analysis and risk assessment. Along with that, there will be justifications of the hazards that we've identified and why we've identified them. We'll have minutes of meetings. We will then have decision tree records, which helped us to identify our critical control points. We will have control charts for our CCPs. We will have procedures for all our CCPs and all our control measures. We will have procedures in place, and then we'll have monitoring for both CCPs and monitoring for prerequisite programs as well. So we work to something called Codex. Codex Alimentarius is a collection of standards, guidelines, and codes of practice, which have adopted by the Codex Alimentarius Commission. It's a central part of the FAO, which is the Food and Agricultural Organization of the UN, and the WHO, which is the World Health Organization, is central to their standards program. They held their first meeting in 1963, and there are 188 current members. Their role and their aims are to protect consumer health and to remove barriers to trade, and this facilitates international trade in a safe manner. They created their first principles of HACCP back in 1962. These were updated in 1997 and again in 2003. Edition 4, which is shown on the screen, was published in 2009 with very minimal changes from 1997. And they have been considering some changes, particularly around definitions. And as we go through some of the definitions, we will see that there are some difficulties around it. We had hoped that following discussions in 2019 that some of these changes may have been published by now, but with our current situation, those seem to have been delayed. So there are 7 Codex principles that we follow. We conduct a hazard analysis, we determine critical control points. For the critical control points, we have to lay down parameters for them to work within, which are known as critical limits, the point between safe and potentially unsafe food. We establish monitoring procedures, which is how we check that we're working within our critical limits. If, when we're checking our critical limits, we discover that our critical limits are not being achieved, then we have to put in place the appropriate corrective action. And then our last 2 are around verification, record keeping, and documentation. So if I was to hand you those 7 principles and ask you to carry out a HACCP study, you perhaps would struggle a little bit. So they have broken it down a little bit further for us into what's known as the logical sequence. And there are 12 steps within the logical sequence. There are what we call the preliminary steps. So you've got 1 to 5, which are preliminary. And then we have our 7 principles falling in between step 6 and step 12. So we start with assembling the HACCP team. We then describe our product. We look at the identified intended use of our product. We construct our flow diagram. We confirm our flow diagram is correct. And then we can move into our 7 principles. I'm going to add 2 principles, 2 steps to that. So right at the top, I'm also going to add defining the scope and the terms of reference. And at the end, I'm going to add review. So it's well documented that we need to define our scope and terms of reference before we can carry out our study correctly. And we also should have a formal review at the end. So these 2 are not part of our Codex logical sequence, but it's well documented that we should add these on. And we're going to use these as we go through. If I'm carrying out a HACCP study, I always follow these 12 logical sequence plus my additional 2, so my 14. And I always find that it's the easiest way. It's like a building block exercise where you do one, when you're happy with that, you move on to the next one. So let's start with the team. You'll find that the team and the defining the scope happen fairly close together. You perhaps need the team to be gathered and meeting to be able to define the scope, or perhaps you will define the scope and based on that, who will be your team members. So they happen fairly simultaneously. So we talk about having a multidisciplinary team. We need that team. I personally have written HACCP plans on my own in the past and have gone back and had a look at those at a later stage. And I clearly can see that I have had results which were very skewed from a quality and technical point of view, that I didn't have the other expertise that were necessary. I've also witnessed teams working really effectively, and I've also witnessed teams not working so well. So some companies have teams which are on paper, but they never actually meet. I have sat on team meetings where nobody actually contributes anything and they all just agree with the team leader. but I've also witnessed teams working really effectively as well. So we use this multidisciplinary approach, and depending on the size and the scale of your operation, who you would have on your team. A core team is normally made up of quality, technical, production, and engineering. And then we bring in our co-opted team members. And these may be very specific depending on your organization. You might have somebody from new product development. You might have somebody who's a packaging expert. You might have somebody who's a chemical expert, somebody with regard to logistics. You might have somebody who's a microbiological expert. You might have to bring somebody from outside your organization to bring some specific expertise in. We normally would recommend 4 to 6 members of a team is normally a good size of a team. Too little, you run the risk of not having the level of expertise required. Too many, and it can be difficult to make the decisions. In smaller organizations, this can be difficult, and you may find that you wear 1 or 2 of the hats. Okay, so you might be production and engineering, for example. You will have a team leader, and the team leader will ensure that the team are following the plan correctly, and that they're contributing and making sure that the quality of the output is there as well. So let's define our scope and our terms of reference. So our scope, what are we going to look at? Are we going to group our products together? Are we going to carry out our HACCP study by process? Or are we going to do it in a modular format? So a modular can be, for example, a module of intake and storage of raw materials, maybe one module. You then maybe move to a weigh up and mixing stage. You then perhaps go into various different modules, so different processes. Some products go through several of the processes, some will only go through 1 or 2. And then you perhaps have a common module at the end with regard to packing of the product and dispatch and distribution. So you may go down that modular approach, or you may use a simple linear approach where you start at the beginning of intake of your raw materials right through to the end of the product. So we talk about intake coming through as our starting point, so intake of our raw materials, and end point tends to be the point of dispatch of our product. I would normally talk about supplier approval and purchasing as being controlled as a prerequisite control. So it's a standard control that's in place for all processes, and distribution normally would be a prerequisite control, unless, of course, you are actually distributing the product, in which case transportation and logistics need to be included as well. What hazards are we going to look at? So there are 4 hazards that traditionally we will look at in the food industry. So microbiological, physical, chemical, and allergens. And you will notice when we look at some of the codex definitions, only microbiological, physical, and chemical are included within the definition, but we have added that 4th one, allergens, in recent years. But more recently, we've also added a 5th hazard in, and there's a lot of debate around whether this should be in our HACCP or not, and that is malicious contamination and fraud. These are slightly different, as in they are what we call intentional. Somebody intends these hazards to get in, whereas the others are purely unintentional. So the experts have a lot of debate about whether these should be included as a hazard. I personally don't believe they should be in our HACCP plan. However, a number of the standards are expecting us to have those in place. So a lot of our GFSI approved standards such as BRC, FSC 22000, and some retailers are expecting those in there. So I do now add them in. I do prefer to have the detail in my TACCP and VACCP, my vulnerability assessment documents, but I now do add those in because otherwise they perhaps don't meet some of the standards. So knowing who you're going to meet standard-wise, you need to look at that and make a decision yourselves whether you're going to include malicious in there. So in order to be able to carry out our hazard analysis correctly, we need to do some background research into our product. And this is where we describe our product. So we need to think about the composition of our product. What are the principal raw materials? What are the origins of those raw materials? So we maybe will find that when we look at a particular raw material, there perhaps could be a hazard associated because of its origin, or even because of its supplier. You may find that a supplier handles a particular allergen, for example, when another supplier doesn't. So there could well be a risk of allergen contamination coming in the raw material. Are there any intrinsic control factors there that we need to consider? And here we're thinking about water activity and pH. So there might be some natural controls that are in place which could ensure that bacteria perhaps will not grow. We need to describe our principal process technologies. So what processes are we putting our product through? Are we putting through a bull chopper where perhaps little bits of blade could fall off? Are we extruding? Are we mixing? Are we blending? What sort of level of machinery are we going through? Are we heat processing? Could we be removing a hazard, for example, by heat processing like a cooking process, or could we be introducing hazards through our process? So understanding that is extremely important. What is the packaging and finished product state of our product? So are we gas flushing? Are we vacuum packing? Sorry. Are we vacuum packing? Are we packing in aseptically? Are we passing in glass jars? Are we packing in plastic containers? How is the product stored? What are the distribution conditions? Is it ambient? Is it chilled? Is it frozen? What is the target shelf life? So under normal conditions, what would be the target shelf life? We need to identify the intended use of our product, and this can be a difficult one. We need to consider who's the consumer target group. You may be producing a product which is for the general population, and within that we need to consider our at-risk groups. So our at-risk groups include the elderly, the very young, pregnant women, particularly from listeria point of view, the immunocompromised, and then we have a fifth group that we add to that now, which are allergen sufferers. So you need to identify your intended use of your product. So for example, you may have identified a company is supplying some egg products, and they've identified the consumer as being from any of the vulnerable groups. However, they are in fact only supplying into further processors where that product is going to be further processed through a cooking process. So their intended use is that perhaps it's going into a bakery and it's going to be further processed. The final consumer then is the intended use of the bakery that they are supplying into. So you need to really understand, have you developed a product? Are you supplying directly into care homes or into hospital catering, in which there could be a risk from immunocompromised there? Have you developed a product which is designed for children? And remember, a child will choke on a smaller foreign body than an adult will. So you would need to consider that. What about the instructions for use? Does the consumer know what to do with the product? Do they know how to store it? Do they know that it has to be cooked prior to consumption? Do they understand the information that you're giving them? What about alternative uses? That is something we need to consider. Could the consumer be using your product in a way that you hadn't considered? An example I have for that is in the flour industry. They would expect that their flour is used in the bakery industry and will go through a heat processing. However, there is a trend where people will often sprinkle flour on top of baked goods, for example, on scones, to make them look more home-baked. And so therefore we have flour being used in a manner that it was not designed. So some flour bags, when you look on the side, it will now have a declaration which will say this should be baked before consumption. So this brings us on to something called prerequisite programs. So once we've gathered all our background information together on our product, we can then start to think about something called prerequisite programs. So before we start our hazard analysis, we need to think about our general existing food safety controls that we have already in our business and make use of those. So whilst prerequisites are not currently referred to by name within the Codex document, they are alluded to. Okay, so the World Health Organization states that prerequisites are practices and conditions needed prior to and during the implementation of HACCP that are essential for food safety. These are our basic conditions that we have within our business. They will control site-wide hazards, repetitive hazards, and sometimes lower risk hazards. And they tend to be hazards associated with the environment, people, fabrication, facilities, and machinery. So you must make sure that the hazards that are there to identify are adequately controlled. So once we can make a list of prerequisite controls, when we get to a later stage where we carry out our hazard analysis, we often will say that a hazard is being adequately controlled by a prerequisite. And here we have to do a gap analysis and make sure that our procedure that we have in place for our prerequisite is adequate and will in fact control the hazard that we have identified. And therefore we need to validate that. We need to have a procedure in place for all our prerequisites. We need to train our staff against those procedures. We need to monitor and make sure that our procedures are being adequately followed, and we need to make sure they're included on our verification programme as well, and regularly review them. So validation of our prerequisites are extremely important. In other words, we want to make sure that they are adequate and that they will work. For example, you may decide that cleaning is a prerequisite control to prevent allergen contamination, where you've perhaps had a product containing an allergen go down the line, and then you do a cleaning process, and you're saying the cleaning is a prerequisite and will make sure that I don't have a risk of contamination with the allergen with the next product. So how would I know that that prerequisite control is adequate? Well, I might first of all confirm that the correct method of cleaning and chemicals have been identified, and I will do this with discussion with my cleaning chemical suppliers and manufacturers. I might do a visual assessment to show that cleaning has occurred. There's no point in doing further testing if it doesn't look clean. I will then do some swabs of the surfaces and equipments to test whether any allergen residues are left behind. I will then perhaps do some lab testing of my finished product to make sure that I can't identify the allergen that shouldn't be there. And you will do that as a control. So you will have a control sample where the allergens should be present. You will then do a full clean down, and then you will test the product to make the first run product after the clean down to make sure that there is no allergen detected in the product. You may do additional testing, for example, looking at cleaning rinse waters to see if there's any residues behind. And you would do that with all your prerequisites. So, for example, another example would be chilled storage. So if you're saying chilled storage is a prerequisite, do I have adequate chilled storage? Do I have capacity to store the product that I require? Will it be able to maintain the temperature that is necessary? What are the impact if I'm opening and closing doors on a regular basis? So you're challenging, it's a validation of your prerequisites. It's all about challenging your prerequisites to make sure that they are robust enough. Where do I get this list of prerequisites from? A good source is from our Codex General Principles of Food Hygiene document. So under the basic text, the first elements of that study look at what I would call prerequisites. So whilst they haven't defined them as prerequisites, that's a really good starting point for you. They look at primary production. So if you're handling food at farm level, then they will have some requirements under primary production. Then they've got the establishment design facilities, where they look at location, premises, rooms, equipment, and facilities. They also look at control of operations, so incoming raw materials, packaging, water, management and supervision of your staff, documentation and record keeping, and also product recall. We've got control, we've got establishment, maintenance and sanitation, so maintenance and cleaning, pest control and waste. We've got personal hygiene, so health status, illness, injuries, personal cleanliness, personal behaviour and visitor policies. Interesting that personal behaviour is in there. So this is, you know, quite an older document, and yet personal behaviour and values and food safety culture was included in there very much. We've got transportation, product information and consumer awareness, which will include things like lot ID and traceability, cooking instructions, storage instructions, and any consumer awareness, and training programs, instruction, supervision, and refresher training. So that's a really good starting point for you. There's also a PAS document, which is useful. So PAS 222-2011 is also quite useful. It looks at prerequisite programs for food safety in manufacturing, food and feed. So it's quite a useful one to look at as well as a reference guide, and even to look at legislation under 852/2004, hygiene of foodstuffs. A lot of the articles and chapters within there are your basic requirements that you would want to have in place. So once we've gathered our prerequisites, and we'll go back to our prerequisites a little bit later, you need to draw a flow diagram. So you're mapping out your process. You include all your raw materials, any utilities that you might be using, for example, water, steam, or ice, any direct food contact materials, how each process and activity interacts with the previous step and the future step, process parameters, storage, rework, recycling, etc. It's important that your process flow diagram is accurate, that it is detailed. I find that process flow diagrams that are very simplified mean that when we go to do our hazard analysis, we miss hazards. So it's important that we put as much level of detail in here. And then when we do our hazard analysis, you will find that it's very specific, because we're going to use our process flow to help us with our hazard analysis. So all of that background information brings us to our hazard analysis step, which is our first principle. And within this, we are looking at identifying potential food safety hazards. We're going to risk assess. So we're going to look at likelihood and severity and pull out what we call significant hazards, and then make sure that we have controls in place. So within hazard analysis, we identify potential food safety hazards, we risk assess with likelihood and severity, and we identify significant hazards. And then from the significant hazards, we must control them. And our controls may be existing controls that we have in place, such as prerequisite controls, and we need to challenge them, make sure that they are adequate, make sure that we have procedures in place, they're documented, and make sure that we are going to monitor them. So what is a hazard? As I already had said, the Codex definition of a hazard is a little bit dated. So a biological, chemical, or physical agent in or condition of food with the potential to cause an adverse health effect. In other words, something which has the potential to cause harm to the consumer, either by causing poisoning, such as food poisoning or chemical poisoning, or causing harm or injury. For example, causing choking or injuring their mouth, cutting their mouth or breaking a tooth, or causing an allergenic reaction. So when we're looking at the hazard analysis, we're always thinking about the harm to the consumer. A hazard is something which has the potential to cause harm to the consumer. We're not thinking about the harm to your employees working and producing your product. That is health and safety. So slips, trips and falls, burns, that is harm to them. That is not included in HACCP. We're not saying it's not important. It is extremely important, but it's dealt with within the health and safety aspects of your business, not within your HACCP. Okay. So let's look at those hazards a little bit further. So microbiological, we're considering the pathogenic, the harmful bacteria. You need to look at, are there any emerging pathogens? So we have in the past talked about emerging pathogens. Most of those have now emerged and are now in our industry. But are there anything new out there? So in recent years, viruses have obviously hit the headlines, and hepatitis E was a virus that was something that we looked at within the pork industry for chopped up pork, manufacturers of sausages, one that they had to consider in recent years. It is easily destroyed by heat treatment, so as long as the sausages were thoroughly cooked, the virus was being destroyed. So making sure that your cooking instructions were adequate was going to be very important. Chemicals, then you've got cleaning chemicals, you've got dioxins, PCBs. Dioxins are chemical compounds from the combustion of organic materials for deforestation, fossil fuels. And we had the case where the wrong oil was used for a drying process for animal feed, and dioxins got into the animal feed. PCBs, polychlorinated biphenyls, which are used in coolant fluids. You've got veterinary drug residues, antibiotic residues, and a relatively new one for us in chemicals is radiological. So you need to think about where your product comes from. Is there any risk from radiation from the area that your product perhaps has been grown, or from where the animal has been farmed from? Physical then, as I said, something causing a choking hazard or cuts to your mouth or dental damage, and then allergens. So we have 14 allergens under EU regulations that must be labelled. So we have what we call intentional allergens, so allergens that should be there. So the control around that is making sure that our products are properly labelled. But we also, within our hazard analysis, have to consider unintentional allergens. So if you're handling other allergens on site, the risk of cross-contamination, or perhaps somebody bringing an allergen on site as well. And then we have malicious contamination and fraud. So we need to accurately define our hazard. So what do we mean by this? This is thinking about how does the hazard actually happen in our process? And if we can define our hazard and give the reason or the source of the hazard, that will make it much easier for me when it gets to the control stage. So we talk about presence, which is typically that it's present in the raw material when it arrives. It could be contamination, which is typically happening due to cross-contamination during our process. We may have multiplication or growth, particularly obviously for microorganisms, where we are allowing them to increase to numbers which would deem them to be unfit. And then we've got survival. So we're allowing them to survive a process which is designed to kill or reduce them down to an acceptable level. And if I can preempt my hazards with one of these words and the reason that the hazard has happened, then it makes it a lot easier. For example, if I'm worried about growth of salmonella due to temperature abuse at storage, then I know what I need to do is control the temperature at storage. If I'm worried about cross-contamination with pieces of metal falling off my equipment, then I know I need to maintain my equipment to make sure that parts don't fall off. So the more specific I can be in my hazard analysis, the better all around. With microorganisms, you'll use one of those 4 words. With chemicals, it's going to be contamination. With physical, it's generally contamination, although remember, you could have presence of physical if it was an intrinsic physical contaminant. So a piece of bone in the chicken does belong to the chicken. So it's a physical contamination if a piece of bone was left behind. It's what we call an intrinsic physical contamination. Extrinsic is where something is added in that shouldn't be there. So we could have presence with physical coming in the raw material, but mainly it's cross-contamination. With allergens, then it's presence, contamination, or it could be survival if it survives a process that's designed to stop the allergen getting through, such as a cleaning process. So when we identify our hazards, we then have to risk assess our hazards. And risk assessment is about looking at how likely it is this hazard is going to happen. And if it did happen, would it cause any level of harm? So the criteria that we use in risk assessment are these: likelihood, how likely is it? And we should consider likelihood without control. So if we didn't have controls, remember your control is there to control the hazard. So if you were doing your hazard plan from scratch, you would look at likelihood without control. And then you would say, okay, without control, how likely is it that this hazard would happen? And then if it did happen, what level of harm could it happen? Could happen? And that's where you need to think about the vulnerability of those and that background information, knowing the use of your product. You will reduce your likelihood by introducing controls, but you will never change the severity. So your controls are there to reduce the likelihood. So you may want to risk assess a second time to demonstrate that your likelihood has been reduced. So you have to think about the level of harm, and you need to define what each of these would mean. So when you're considering your risk assessment, you need to take into account the likelihood, the severity, the vulnerability of those exposed, how these pathogens that you're concerned about could survive or multiply. Is it likely that there is going to be toxins present or chemicals or foreign bodies? And you need to validate your information. So your information sources are extremely important, and that's why having the right people on the team, again, are extremely important. So I use a very simple risk assessment approach. A 3x3 matrix is what I would use, where I've got low, medium and high. So low likelihood with low severity, medium severity or high severity, and then medium with low, medium and high with low, medium and high. I've color coded them in traffic light system because it makes them slightly easier to look at, but it still can be difficult. If I look at low and low, so low likelihood with low level of severity, I would say it's not significant, whereas something that I'm saying it's highly likely to happen and the level of harm is high, yes, I can see that's significant, but it can be difficult to find those. So if I put numbers in instead, so low has a number 1, medium has a number 2, and high is a number 3, then I then have a numerical score to look at. 1 being your lowest, 9 being your highest. 4.5 then would be your midway point. We don't have a 5, so you may go for 4 and above being significant or 6 and above being significant, and then it makes it a little bit easier. But you must define what each of those numbers mean. So low or 1 might be for likelihood, it's never happened or it's very unlikely. 2, medium would be that it's happened but not very often. 3, high, it's happened a lot. For severity, you might be looking at low, there's slight discomfort to the person. Medium might be that it causes some level of food poisoning, and high could be death. But it can be difficult just to define that. You can use a 3x3, you can use a 5x5, you can use a 10x10. Just be cautious that if you use too many options, then you spread the hazards across. So Codex says that all significant hazards, so whether you're using 4 or 6, need to be controlled. So what is control? Control is a procedure. So always remember that control is a procedure. It's an action or an activity that's used to either prevent or eliminate a food safety hazard or reduce it to an acceptable level. So you will find that a lot of your controls are existing controls that you have in place, such as prerequisites like pest control, cleaning, personal hygiene, planned preventative maintenance, control of waste, segregation, time management, calibration of equipment. So lots of your controls will be there. If you're identifying that your control is a prerequisite, then you do need to go back to it and make sure that those are adequate and it is adequately controlling the hazard that you've identified. For example, you may be worried about a bit of blue plastic glove breaking off and falling into product, and you would be then saying, well, actually, that is controlled by a prerequisite. Well, does your actual personal hygiene prerequisite control that you're saying controls this hazard actually talk about blue plastic glove control? Does it say that they need to be changed regularly? Does it talk about if it gets ripped or torn, what to do? Are staff adequately trained against that prerequisite? So it is important that we look at that. When we identify all our significant hazards and controls, then we document that down and we make sure we have adequate procedures in place and we train those out. But then it brings us on to identifying critical control points. By definition, everything cannot be critical. So what is a critical control point? It's a step where control can be applied. It's essential to prevent, eliminate, or reduce the food safety hazard to an acceptable level. So remember, it's a step in your process that becomes critical. You can use the decision tree here on the screen to help you, and it's a series of questions. As long as you substitute the words in, the decision tree can be very helpful. But often we will say that if it's controlled by a prerequisite, we won't put it through the decision tree because otherwise we end up with more CCPs were identified when actually we're happy that they're already being controlled by a prerequisite. And that is a relatively new methodology in the last probably 10 years that Camden have introduced and works very effectively for us in the industry. So it's usually the last step in the process where we can control a particular hazard. And if we don't control at this point, then it's unlikely that any other step in our process will control it. So heat processing, cooking, UHT processing, metal detectors, X-ray machines, chlorination are often common critical control points. Sieves tend to be critical control points, but in some industries some people will define those as being prerequisite controls. So once we identify our CCPs, and remember from the model earlier on, it's a relatively small number of steps which are deemed to be critical. We then need to lay down parameters for these to work within, which are known as critical limits. And critical limits are a criteria that separates acceptability from unacceptability. So safe food from potentially unsafe food. It needs to be measurable, preferably by a test or by an observation, and must relate back to the hazard and to the control. We set up our critical limits using industry best practice. We might be using legislation to help us. We might be using scientific information to help us decide on what the critical limit is. You need to validate your critical limits and be able to prove that that critical limit will ensure that we have safe product. So if you're using a cooking temperature, then you need to make sure that you know that that cooking temperature will knock out the critical limit. That critical limit will knock out the bacteria that you are particularly concerned about. So you need to do your research on your critical limits. But if there are legal requirements, which they are in some cases, that can be helpful. We need to then check that our critical limits are being followed, and this is what we call monitoring. So conducting a planned sequence of observation or measurements of the control parameters to assess whether a CCP is under control. So with monitoring, we need to consider the type of monitoring that we're going to use. Continuous online monitoring with data readers is very useful because it gives us a continuous readout of the parameters of monitoring, and we know whether we're in control or not. And batch monitoring, however, does have to be used on occasions. And batch monitoring, we will then be perhaps looking at something every couple of hours or every hour, and you need to decide what is an appropriate, what is a batch. You need to define how monitoring is carried out, so the methodology, and you need to have a procedure for that. Who is responsible for monitoring? What is their role and responsibility? What equipment are you going to use? Is that calibrated? Who calibrates it? When does it need to be calibrated? Do I have backup devices available? Where do I record this information? And remember that your record is proof that you have produced safe product. but it also may be used as a due diligence defence, where you need to then go into court and you need to prove that your monitoring was carried out. So verification of that monitoring is important, where we're making sure that monitoring procedures have been carried out correctly. So we need to be looking at how the monitoring is carried out and is it being done. The vast majority of the time when you're monitoring against a critical limit, you will discover that you're in control and that you're producing safe food. And we want that to be the case. But as what I would call an unusual activity, on occasions you will find that the critical limit is not being achieved. And in these situations, we have to establish corrective action. So corrective actions are actions to be taken when the results of monitoring at the CCP indicate a trend towards or actual loss of control. And it may be a trend towards actual control if you're using something like a target level that you're monitoring, which is a little bit more stringent than your critical level, and that buys you a little bit of time before you go out of control. So there are 3 types of corrective action. So 1, regain your process control. Until you do that, you are continually producing potentially unsafe product. Deal with any non-conforming product, which may be reprocessing it, it may be disposing of it, and maybe downgrading it. And then root cause analysis. Why did it go wrong? What can we learn from this? And how can we prevent that from happening again? So within corrective action, we have our immediate corrective action, and then we have our longer term preventive action. And we need to define who is responsible for all levels of corrective action. And we also need to verify that our corrective action has been closed correctly. And that brings us to our latter stages within our HACCP plan, which is verification, which is principle number 6. So the application of methods, procedures, tests, and other evaluations in addition to monitoring to determine compliance with the plan. There are 2 stages. One is validation and the second is pure verification. So we do validation before we implement our plan, and then we look at validation on a regular basis as well. So validation is obtaining evidence that elements of the HACCP plan are effective. In other words, is it correct? If I follow this plan, will I have a safe product? So this is very much going back after you've designed it and saying, before I implement it, is it right? And it's important that we check that it is validated. So we're saying, are the critical limits correct? Are they the point between safe and unsafe food? Will the monitoring be able to detect loss of control? Is the frequency of monitoring correct? Have I got my records in place ready to go? Has it included all my hazard or all my processes included? And I can go on validation for a much longer time, but just to make you aware of it. Once we've validated our plan, then we can implement our plan. So this is our everyday product safety, where we take our validated plan and we implement it into our process. So what do we need to consider? We need to think about people. We need to think about the training of those people. We need to think about equipment that we might be using, including monitoring equipment, maintenance and calibration of all of our equipment, procedures and records that we're going to develop to keep as proof. Then we move on to verification, the second part, which is audit, data analysis, and sampling and testing. So audit is a way of checking that we are complying, that we're doing what we said we would do. But a second method of verification is data analysis. So we create lots of data, and that can be proof that we are actually complying with our system. And then sampling and testing. So you may remember early on in the presentation, I mentioned end product testing, which I am old enough to remember we used to rely on very heavily. We now use that as a verification tool, where we're actually making sure that we have managed to produce a safe product by following the plan. We need to establish documents and records, and these are key. So for our prerequisites, we need to have procedures written, and we need to train our staff against it. For all our control measures, we need to have procedures. For our CCPs, we need to have procedures, work instructions, and we need to train our staff against those and have evidence of that training. We also will develop records to record down any checks that you're doing, any monitoring that you're carrying out, and these need to be authorised. So not just simply coming along and checking that the record has been completed, but checking that the record has been completed properly and that the tasks have been carried out properly. So part of that will be done during your verification. We also need to make sure that we have maintained corrective action records. So when things do go wrong, don't be frightened about recording if a critical limit has been not achieved. It's what you do about it that's important to be able to prove your due diligence defence. And then finally, review. So review should be a scheduled activity. I would recommend an annual review of your plan, and thereafter when changes happen in your process, you should review as well. So for example, changes in your raw material, your suppliers, they could be introducing new hazards that you hadn't previously considered, changes in ingredients or recipe, changes to process conditions or packaging, changes in consumer use, or developments in scientific information. So it's always important that we keep ourselves up to date with any changes as and when they would arise. So future for you, emerging pathogens, be aware of any emerging risks or pathogens as they come to light. Allergens may change. We are aware that out with the 14 allergens, there are other allergens that we know that people have problems with, and we are waiting to see if some of those will be added to the European list. And any verification evidence that you have, and obviously if you move into new markets, you should look at that as well. Thank you for listening to my presentation today. These are my contact details should you have any further queries. I train a lot in HACCP. I can spend 4 full days talking about HACCP. So obviously in a short period of time there, I have tried to condense that down, and I hope you find that useful. Thank you.
Perfect, thanks.
Would you stop sharing the presentation then, yeah?
Yeah,
that'd be great.
Thanks, Lynn, so much for taking time out today to give us a very informative presentation on all aspects of HACCP for small food businesses. I suppose I'd just like to let everyone know that Lynn's presentation will be available on the Safe Food Knowledge Network website shortly. And if you haven't signed up, you can do so and get free access at safefoodkn.net. I suppose Tracy mentioned earlier too that if you have any questions now for the question and answer session, you can type them in at the bottom of your screen in the Q&A box. And we have some questions in there already, Lynn, so we'll kick off the Q&A session now. Okay. So the first one we have there is, what is your review of a HACCP plan with no CCPs? For example, a sausage manufacturing HACCP plan.
Okay, there certainly has been a trend in recent years to remove CCPs, and a lot of food processing factories now have very, very few CCPs, perhaps don't have any. So in sausage manufacturing, it is a raw, I'm assuming that you're talking about a raw product coming through the process there. So from a microbial point of view, a lot of your controls around prerequisite controls around chill temperatures is damage limitation, and the ultimate control will be when the sausages are cooked by the consumer. So it is perfectly acceptable not to have any CCPs there. The only one that I would perhaps be looking at maybe would be if you have a metal detector at the end of the line or an X-ray machine. I would personally expect that to be a CCP. However, there are some people who don't have that as a CCP anymore. Hope that answers your question.
Perfect, thanks, Lynn. Another one we have here is, let's see, can you give examples of steps that are usually CCPs, but in some cases are PRP controls?
Yeah, okay. So that is just an area where we are seeing people maybe removing CCPs, or they maybe traditionally have had something as a CCP like a sieve, and they're maybe now saying, well, you know, actually everything goes through the sieve, all the dry ingredients go through the sieve, so I am not really thinking that that's a CCP anymore, and they maybe make that a prerequisite. So we actually have a new level that I didn't talk about today, which are called operational prerequisite controls, and a lot of the larger manufacturers are now starting to introduce that. That's a new thing that was introduced through ISO 22000. So it would be an example of something which maybe would be a prerequisite control, but it's very specific at a step, and we then make it an operational prerequisite. So it's a bit of moving terminology around and what we call things, but in the end of the day, it doesn't matter as long as we're controlling them. What we find is that people are still doing the checks, for example, in the sieves in an identical way. So whether you call it a CCP, a prerequisite, or even an OPRP, then I don't have a huge problem as long as it's controlled.
Okay, and I think someone's just typed a question following up to that. Well, metal detection, CCP or PRP, and why are there two approaches?
Yeah, okay. I personally believe that the purpose of a metal detector is to detect metal, and if you put it through the decision tree, it clearly comes out as a CCP. Some people have taken the view that it's not. So I recently had a situation where a company had made it a prerequisite and I challenged them, and their rationale was actually very good. The reason was that their product was not going to the end consumer. It was going on for further processing, where it would then go through further metal detection at a more sensitive stage in the process, and therefore they had identified it as a prerequisite. So different approaches. HACCP is all about justifying your decisions. Nobody really can come in and tell you your HACCP is right or wrong, although they will try to do that. So if you can justify it in this situation, I was doing some HACCP refresher training with the client, and I challenged them, and they actually were able to eventually get their justifications out that were very sound.
Okay, we have a question here too. If you're now operating a takeaway due to COVID, do you have to update your HACCP plan?
Absolutely. Any changes in your process, you should be considering that. And it's actually one of the areas of concern that I really felt was a big potential problem for the industry, where a lot of restaurants were perhaps moving into takeaway where they probably hadn't done that before. So absolutely, you should review your HACCP plan and see if there are any additional steps that you're doing or additional hazards, because your product is then going out to the consumer and you're potentially sending it out to them as a takeaway, and you're maybe putting it out into packaging. You could be introducing hazards, or a lot of restaurants are providing ingredients and instructions for the consumer to cook at home, and there are very specific hazards with that. So absolutely, you should be reviewing your HACCP plan and making sure it's up to date.
Perfect, thanks, Lynn. Another question: how long do you have to keep records for? Is there a length of time?
Yeah, the rule of thumb is normally for the shelf life of your product plus a year. I would normally say a minimum of 5 years, but be aware that you could be prosecuted down the route beyond that time. So I know from a document control, from a financial point of view, companies keep records for 7 years. So some companies will keep them for that length of time. I normally would say 3 to 5 years. That can be a problem. You know, you can create lots of records. So where are you going to keep them, and how do you make sure that you have them in a safe, secure place?
Okay, thank you, Lynn. Now another question we have. If you have a meat distribution company and you operate out of a refrigerated storage unit where they manage the temperature of the storage unit, do you need to monitor the temperature and take records twice a day, or is it sufficient for their alarm system to operate this?
Okay, could you just read that out again to me?
So if you have a meat distribution company and you operate out of a refrigerated storage unit where they manage the temperature of the storage unit, do you need to monitor the temperature and take the records twice a day, or is it sufficient for their alarm system to operate this?
Okay, so I think in this situation, it is what we would call third-party storage. So you are relying on another facility managing this for you. So you would need to risk assess that, audit that facility, have a look at their alarm system, which would be useful. But I would be expecting that they would do some manual backup checks throughout the day as well. The frequency would be dependent on themselves to decide, but you would be relying pretty much on the alarm, the automatic, the ongoing system, but you would need to be making sure that that system is robust and it's not going to fail. So I would still expect some manual checks to be carried out as well.
Okay, thank you, Lynn. Okay, another one. When someone operates all parts of the business and maintains the controls of all processes themselves, for example, a home baker, is there a refined, slimmed down food safety plan that's available, or is the approach just to eliminate the parts that aren't applicable?
Okay, there are some very useful models available within Northern Ireland, and I know FSII do promote this as well. Is safe catering is a really, really useful tool to help guide you through HACCP for smaller businesses. Now, although it is designed for catering, if you had quite a small bakery, you may find that as a useful starting point for you. And what it has done is taken the jargon and broken it down. For example, when it says, it'll say what can go wrong, and then in brackets it will say hazard. And what do I need to do about it? Brackets, control and critical limit. How do I check it? Brackets, monitoring. What will I do if it's wrong? Brackets corrective action. So it is taking the jargon and broken it down and actually giving you examples of prerequisites and giving examples of controls that you can put in place. Added bonus there is that they actually have developed record forms for you as well, so you can download those and use those. So that might be a useful starting point for that person.
What we can do is we'll send on links when we send out the recording to participants to the signposting into resources like that.
Yeah.
Yeah. Okay, we have one more question. So, can research paper suffice for validation of microorganisms present in raw materials, or would lab testing of the raw material always be needed?
No, I think you could use research information to help justify the potential hazards that would be there, because you could test for them and not actually find them. But where your testing would then come through is perhaps making sure that they're not present in the finished product.
Perfect, thanks. That's all the questions that have come in now this morning. Thank you so much, Lynn, for taking part this morning.
Welcome.
And as I said earlier, if anyone would like to view the presentation again, it will be available on the Safe Food Knowledge Network website shortly in the next few days.
Okay, thank you. I apologise, it was quite a rushed presentation, but I hope that I was able to give you a flavour of HACCP in that.
A lot was covered off. Thank you very much, Lynn. Thanks, Mairead. And thank you everyone for attending. We'll end shortly. Thank you.